This is Geometry, Unit 11, Lesson 2 on circles. In this lesson, we're going to be looking at the circumference or perimeter of a circle, and also the area of a circle and where the formulas come from. So, the circumference or perimeter of a circle is the distance around the outside of the circle. So, if we have the circumference of a circle with a diameter of 1, so here's your diameter of 1, the circle is drawn like this, going around in a circle, because it makes a circle. Okay, now, if we think of this as unrolling the circle, so we start here and we start rolling the circle like this, and then we're unrolling it so this piece ends up here. So it rolls like this, and if we unroll it the whole way, all the way around the circle, so it goes around like this, and then around like this, and around like this, if we get to the end here, it actually ends up about right here, all the way around the circle. Would be like that if we unroll it. So when the circle rolls once around its circumference, it is rolled a little more than 3 units. It is actually rolled exactly 3.141592653 ... units. Well, where does that number come from? That is pi. So the distance around a circle with a diameter of 1 is pi. So if the distance around the circle with a diameter of 1 is pi, and then we dilate it, remember dilation means you multiply it by a scale factor of something. So if we make this d times larger, the new circle is similar to the original circle. All lengths in the new circle will be d times the corresponding length of the original circle. So if the circumference of this circle is 1 times pi, the circumference of this circle, if we multiply the 1 times d, it's going to be pi times d. So the diameter is equal to 1d, and its circumference will be pi times d. So this brings us to the formula for circumference of a circle. The circumference of a circle, for a circle of diameter d, c is equal to pi times d. Now, remember that a diameter is actually made up of 2 radii. So you can also say that d is equal to 2r, so you can also see it as 2 pi r. It's on your reference sheet as both pi d and 2 pi r, so you see this, it's both ways. You can use either formula depending on the information that you have. So pi d or 2 pi r is the circumference or distance around the outside of a circle. Now the area of a circle is the space that is inside the circle. It's the space that the circle covers. So where does the formula for area of a circle come from? Well, let's take a look and figure it out. Okay, so I have some circles here that I have divided into equal sectors. So this one is divided n equals 4 sectors, 1, 2, 3, 4. And if you rearrange them so that they look kind of like this. So the radius here is actually right there. That's the radius. And then this outside piece would be right here. So if we put them all together like this would be a radius, radius, radius so far. And this would be the outside of the circle. All right, the more that we divide it, here's n equals 6. It's divided into 6 sectors. This is the radius, and this would be the outside of the circle for each one, the curvy part. All right, 12 sectors, this would be the radius, this would be the curvy part, and 24, this would be the radius, this would be the curvy part. Okay, now notice as we divide this into more and more sectors, as the circles divide into larger and larger number of sectors, the rearranged figure becomes closer and closer to A. What kind of shape does this look like? Well, it kind of looks like a parallelogram. Okay, so that is a parallelogram. Okay, so if we keep dividing this into an infinite number of sectors, what does the figure become? Well, if n approaches infinity, if you did this in an infinite number of sectors, it's going to look like a rectangle. So if that's a rectangle, all right, so this right here would be your radius, that would be right here. Okay, now, to go around, remember this is put together by different sectors, this side and this side would be the whole outside of the circle. So this would actually be the circumference of half of the circle, and so would the other side. So C would equal this would be half of C, half the circumference. And this one would be half of the circumference. Okay, so if this put together as sectors becomes a rectangle, well, we know the area of a rectangle is base times height or length times width. So the length on this would be 1/2 c times the width would be r. Now, since this is c here and this is r, we want the same units. What's another way we could write c? Well, c would be 1/2 times 2 pi r. And then multiply that by r. Multiply these together. You get 1/2 times 2 pi r squared, and then multiply it by 2, or by 1/2, excuse me, we get pi r squared. So the area of circle formula is pi times the radius squared. That's where the formula comes from. So the circumference of a circle is pi times the diameter, or 2 pi r, and the radius, or excuse me, the area of the circle, the space inside the circle, is pi r squared. So that's where the formulas come from. All right, so let's look at some application formulas from the information that we have here. The mouth of the tunnel is in the shape of a semicircle, which is a half circle, with a diameter of 24 feet. So the distance from here to here is 24. Okay, so we want to find the perimeter of the tunnel mouth in terms of pi and also round it to the nearest tenth. So you may be asked to find each of these values, so you have to know which one is which. All right, so if we're doing the perimeter, do we want the circumference or the area? We want the circumference. Okay, so we want to figure out how far it is from here to here and from there to there. So that would be the perimeter. So in terms of pi and round to the nearest tenth. Okay, so the perimeter would be the 24 plus the half circle. All right, so it would be 24 plus the half circle. Okay, so we need to know what the half circle would be. Well, let's see. This would be circumference because it's on the outside, and it's a half a circle, so whatever the circumference is, we multiply it by a half. Okay, now, since I have d is 24 here, I'm going to use pi d. So it's 1/2 times pi times 24. Okay, now it says in terms of pi. So this is going to be 24 plus 1/2 times 24 is 12 pi. Now that is the exact answer in terms of pi. Because remember, pi is an irrational number, so we can't add these together because this one has a pi on it and this one doesn't. It's like saying 24 plus 12x. You can't add those together because it has an extra term on it. So that is the exact perimeter of the tunnel mouth in terms of pi. Now if it says rounded to the nearest tenth, you would put that in your calculator. So it would be 24 plus 12 pi. So you put the whole pi in your calculator and press enter, and it says round to the nearest tenth, so this would be 61.7. So it will be approximately 61.7 feet. All right, so that's the nearest tenth. So this is exact, and this is rounded. So depending on how you work it out, how the question is asked, you have to know which form it should be in. If it says in terms of pi, leave the pi in it. If this is rounded to the nearest tenth, you want to round it off appropriately. Put the whole answer in the calculator and round it off afterwards. Okay, now part B says, find the area of the tunnel mouth in terms of pi. All right, now remember, area is the space inside. So the area, we're actually looking for this right here. Okay, so area formula is going to be pi times the radius squared. Now notice on this, we're not worried about the 24 here because that's the outside of the circle. We're just looking for the space inside. Now remember, since this is half a circle, it's actually going to be 1/2 pi r squared because it's only half a circle. So A equals 1/2 pi, and what would be the radius if the diameter is 24? Well, if d is 24, that means r is going to be half of that, which is going to be 12. So that's going to be 12 squared. So multiplying this out exactly, 12 squared is 144. So it's 1/2 times pi times 144. And then half of 144 is 72 pi. So exactly 72 pi square feet because units squared, which is approximately, you put 72 pi in your calculator, 72 pi, and it comes out to be 226.2 when we round it to the nearest tenth square feet. So that is the rounded, this is the exact in terms of pi. Okay, so you should be able to interpret both of them. All right, last question. Round Valley Reservoir covers 3.6 square miles. It's not really round, but if it were, what would its radius be to the nearest foot? Okay, so since we were talking about square miles, this is an area formula. So we need, if we're doing a circle, it would be A equals pi r squared. Use your formula. Okay, now, it says if it covers 3.6 square miles, that's the area. So the 3.6 is going to go here. Okay, now, what would its radius be to the nearest foot? We need to know what r is. So to solve for r, we've got to get it by itself. So we're going to divide by pi. So we get r squared is equal to 3.6 over pi. Now, I'm not going to evaluate pi, and I'm going to put that in my calculator, so I'm going to leave it as is right now. To solve for r, I've got to take the square root of both sides. So I'm going to take the square root of r squared, and I'm going to take the square root of 3.6 pi, over pi, excuse me. So this is what I'm going to put in my calculator. So I do the square root of 3.6 divided by pi. Okay, and I get this answer. It's 1.07047,447 approximately. So r is equal to 1.07047,447. What units is this in? It's in miles. Okay, now, but what would its radius be to the nearest foot? Well, if this is in miles, we have to know how many feet this is. So this, remember, there is 1 mile is equal to 5,280 feet. So what do we do with this? We multiply it by 5,280. So I would take this answer, grab your calculator, take this answer right here, multiply it by 5,280. And we get 5652.1052. So it says to the nearest foot would be 5652. 5,652 feet. And that is your answer that you would do. Okay, so your formulas are very important. You need to know C equals pi d and C equals 2 pi r for circumference, and area is equal to pi r squared. They are on your reference sheet, but it is helpful if you know them as well.